training number 1 for EclipseStore/MicroStream. I hope every one of you joined the fundamental training before, or some of you joined the advanced for the first time now. How is it? So who took part at the fundamental training of you? Okay, looks good. So no worries, we will cover all that basic fundamental stuff in the first round of the training. And I tried to clarify most of the stuff of the fundamental and also your question. And that brings me to the first slide, and also an important note that the training will be recorded and you will get access to the recordings afterwards. So sometimes it took us around 5 to 6, 7 days because the video has to be cut and then we will share it. But yeah, it takes a little bit of time. So about me, so my name is Christian Kuemmel. I'm senior Java developer, project manager. I started Java developing around 15 or 16 years ago. I switched over to project management. Then at the moment, I'm project manager of the MicroStream cluster development. And at the same time, I'm also involved in some projects with the Allianz insurance company in Germany and also on Fraport German airport. I have to say most of the projects are using MicroStream or EclipseStore as a storing technology, and that's also why I'm involved to that project. Some of them are using clustering also, and that's also the reason why I'm part of that project. Sometimes, or most of the time, I'm also doing the trainings and some conference speaker parts, for example, JCon or other conference all over the world. And if there are any questions, feel free to contact me. There is my email address is down there. Just write me an email and I will do my best to answer it. Okay, this is the timetable for today. So we started at 5. We will have a short break somewhere in between 6:30 and 7. It depends a little bit on the topics where we are. And the training will took till 9. I left enough space for your questions. I think that's also a very important information to you. Ask as many questions as possible. That's a training for you. And yeah, I will do my best to answer everything regarding EclipseStore, MicroStream, or other technologies if enough time. And you will get access to the code repositories. There are a lot of projects I prepared for you. And that's the first thing I want to share with you, all the links that we need during the training. And give me just a second. There is a lot of stuff incoming in the chat, but these are all the links you will need within the training. So most of them are part of my GitHub repository. So it's the training examples down there, github.com/sorgck. That's my GitHub repository. And I will share you every project link at the beginning of each topic. And then feel free to code along with me or to have a look just to the code. Most of the projects are divided into several branches. So that enables you to code along with me. And if anything goes wrong, or then just switch to the last branch and you are good to go for further development. One information regarding the certificate. The certificate will also be available 5 to 7 days after the training at our cloud front end, which is available in cloud.microstream.one. Let me just show you this. Just a second. So when you call cloud microstream.one dashboard, you will find the certification here. And after the trainings, as I said, 5 to 7 days after, you will find your certificate here. Just click on that button and then you will get your certificate. It's important for me to have your name within the training. So for those of you who just use 2 letters like FB or MV, for example, I have to map your name to your order of the training. And that's why it's important having more than FB, for example. That makes sense. That makes it easier for me to who takes part to the training. Okay, good to know. And then you will be able to get your certificate at the end. And another information is just use the same account for registration to the cloud front end as the registration for the training. That's also important. Or use the same email address. That's important. Okay, I already shared all that links. And as I said, after 5 to 6 days after the training, also the certificate will be available. So now time for the topics. So what are the topics for today? So as always, I start with a small warm-up project to cover all the topics from the training before. In our case, it's the fundamental, so it's not that complicated warm-up project exercise. Sometimes if there are not that much people on the training, I give you time to do the project, but for now and for today, I will do it directly together with you, and you can code along with me. And at the end, you will have a full functional project exercise, and that covers all the topics from the fundamental training. And then we switch over to configuration advanced to give you an idea what further configuration you could do, what configuration is important, how about channels, how about data locking, that's important. Then I will also cover the S3 bucket topic. Some of you are always asked for how to use an AWS S3 bucket as a storage target. And it's also about the Micronaut integration. The reason for Micronaut here is in my trainings, I mostly use Micronaut as a data provider, just to having some interfaces at the end to calling data, storing data. That's why I'm using Micronaut a lot. So that means you will need to code along with me and any idea of your choice, which can handle Micronaut projects. So that's important. Yeah, then we move on to storing advanced. So we want to talk about what does storing mean? I mean, most of you already knows the store methods, but there is some more stuff behind the scenes, what you could use for storing, like transactions, rollbacks, some important exception handling when using EclipseStore. It's all about the best practices when we store with EclipseStore. And then we're talking about lazy loading. That's also an interesting topic. Some of you will not have all the data in memory, so it's important to find a solution how data could stay on the hard disk instead of the RAM. Possible lazy structures, mostly the lazy loading, it's a quite easy topic, but in deep, it's important to know what data structure fits best to handling data in a lazy way. And in the same way, we want to talk about LegacyTypeMapping. What happens if some changes in my class appears or when I have to change something. And we also have to talk about backup strategies. So what about continuous backup, full backup, and also backupping stuff to an AWS S3 bucket. I prepared some projects and examples for that. And yeah, all over questions and answers all the time. So if there are any questions, feel free to answer. Okay. Yeah, there is one question from Arthur. Will recording be available later? Yes, it will. So I already mentioned that it took us 5 to 6 days to cut the video, and then we will share it with you. Okay, some further question at the beginning. Let me just double check the chat. No, so we could go on. So as I promised, we start with a small warm-up project. At the beginning, I want to summarize EclipseStore a little bit for those of you who did not join the fundamental training. So EclipseStore is basically a Java framework. It's a from scratch invented object graph serialization. And it serializes data to most known systems like file system, AWS S3, Kafka, and many, many, many more. And the special thing is here, we are able to update the serialized data partially instead of storing the whole graph again, and again. So we are able to update partially, and most of the data stays in memory. That's one thing. Why is EclipseStore that fast at the end? And there is no data mapping anymore. So there is no OR mapping anymore in between. So there is only one object graph which is needed. And this is the object graph on the Java side. There is no database related data structure anymore. That's why we do not need any mapping anymore. And that's it. Okay, so let's jump directly to the exercise. There is one project I'd like to share with you. So just a second, you will get the link directly. So here it is. GitHub car exercise. And you could directly start at the branch. There is one branch which is called start exercise here. And I will do the same. So we have to complete the following classes. There is one class which is called storage.db. And yeah, we need to implement some controller classes, a car controller and a brand controller. You see, it's all about handling cars and brands and stuff like this. We have some special configurations that we want to have. We want to have a channel count of 2. And the store target should be data at the end. Yeah, and that's it. So, but no worries, we will do this. We will do this together. And let me clean up my screen a little bit. And that brings me also to the car exercise project. I'm still on the master branch. Let me also switch to start exercise here. And here we are. So let me also double check the right side of my monitor. So main. Okay. Okay, great. So, so I'm good to go so far. I'd like to start with the DB class. And most of you or some of you might wonder a little bit why I use Micronaut at the end. And sometimes I'm using static classes instead of a dependency injection and so on. The reason for that is the training is all about EclipseStore and MicroStream, and it's not a training for Micronaut. I'm using just the project itself, and sometimes it's easier having some static classes. And it's also the case that some of you do not have any experience in dependency injection and so on. That's why I'm using both in some projects. And yeah, sometimes it's not the right way to use Micronaut, but that is because to keep it easy and simple and more understandable for you. Okay, so the DB class, you see it, it's empty. And the first thing we need always is the dependency. So as I already explained, just here is the project itself. If you check out the project to your IDE, you could directly open the POM XML, and you will see everything is really straightforward. And the most important dependencies you will need are these two dependencies, the storage embedded, org.eclipsestore.store, storage embedded. That's the main dependency, I would say. And we need a second one, which is the storage embedded configuration to do some further configuration stuff at the end. So we will talk about initialization of the DB class in a further project or in the next project. But it's important to use these two dependencies, and they should be already available on that start exercise branch. So the current and the latest version is 2.1.2. And this is the version we start with. As far as I know, the guys from Micronaut are currently working on upgrading the EclipseStore integration. That's why I not use the Micronaut integration now with version 2, because I think the latest version of integration is 1.8, I guess. So it's easier to use it this way. Okay. So these two dependencies are already available. And that brings me to the DB class again, one of the most important classes to initialize the two major objects that we need. And one is the embedded storage manager. That's the first instance we need. So let's create it. So let's say public static embedded storage manager, and let's call it storage manager. That's all we need. And another object which is important is the root object. And as you already know, sometimes the root object could be a synthetical object. That means any object, let's call it root or whatever, could be the master node on top of your object graph. But it could also be a business class. And in my example here in that project, it's the company class itself. So let's say we are a car selling company, and our company consists of a name and has a list of cars and, of course, a list of brands. As I said, it's just an example project, but the company itself is our root object at the end. And that's also the reason why we create a new instance of public, let's call it final static company. Let's call it company, or let's call it root to make it more understandable, equals new company. I think the way to initialize the storage manager and the root object itself, there are 1,000 ways of doing that. And you will see in some other projects that I share with you, all that stuff is different. And to be honest, I did a big mistake today. I updated a lot of projects today, and we will see some error messages at the end, but I will do my best to cover that. Okay, so that means, so we need two instances of a storage manager, which represents the database itself. And we need one root object as the root entrance object to the whole object graph, which is handled by the storage manager. Okay, so let's create a static block to do the initialization. So that means whenever we access the DB class, then these two objects will be initialized. And the initialization of the storage manager, we will do it now. So let's say storage manager equals. And the way we initialize that storage manager now, and that's one way doing this, is we are using the builder pattern. And the builder pattern works with the embedded storage configuration dot builder. And now we are able to set all the different configurations that we need for the project. So that means we could start with okay, set channel count. That's what we want to set. And you remember, we want to have the channel count of 2. What the channels are, we will talk about this a little later. But we will need a channel count of 2. Then we will also set the file path, and for that we say set storage directory, and let's call it data storage directory. And it's always when we initialize EclipseStore, it's always there are always 3 steps, or let's say 2 steps. So first we create a configuration, and based on that configuration, we create a foundation, create embedded storage foundation. And that's the reason why, we call, come on, what's going on here? Create embedded storage foundation. And based on that foundation, we create the embedded storage manager. And you see that there is a second constructor here that enables us to hand over the root object. And this is what we want to do. So we want to set directly the root object as the major entrance point to the object graph. And after that, it's really important to call the start method. Otherwise, your storage will not start. That's absolutely necessary to call that start. I think these 2 elements here, root and start, are some of the most made mistakes by initializing the storage manager, also by myself. So I forgot to hand over the root, and I'm wondering why EclipseStore is not storing anything. Yeah, sometimes it's quite easy. Okay, that's it. So that's all we need to initialize a storage at the end. There are, as I said, there are several ways doing that. Instead of having that static here, you could use a constructor and initialize this in a non-static way. And then you will be able to inject the DB class to other classes. But for now, I think we are good to go. That's easy to understand, and we use it in a static way now. Okay, any questions so far? Channel count, storage directory, quite easy, straightforward settings. Nothing special. Okay. So move on. Let's move on. Let's have a short look to the domain classes here. We already looked at the company. So there is the name. There are a list of brands and a list of cars. Maybe one important question. Why do we need a list of brands here instead of having the brand directly within the car? So let me just double check. You see that here. Also, the car has a brand in it. But the question is, why do we need the brands as an extra list? Any ideas from your side? Why is that necessary, or why could this be necessary, having that list? I think it's quite obvious. The reason could be whenever we delete cars or we are removing cars, and we are removing, let's say, the last BMW from the list of cars, we will lose the brand BMW at the end. And when we want to fill a combo box for choosing a brand on a UI or whatever, then you will have a list of all the brands within your system. And for not losing the brand by removing the last BMW, we have the list of brands here to cover that situation, storing all the brands of my application. Okay, so that's why we have a list of brands here. We have cars, and you have also always take care about when you add a car with a specific brand, you also have to take care about having the brand also in the list of brands. That should be quite clear. Okay, so let's jump into the car. I think there is nothing interesting here, but again, from my side, just the hint that there are no annotations or no data mapping anymore needed. And it's the same on the brand side here, a really straightforward domain class, nothing special, just an entity. But again, no annotations needed and so on. Okay, and that brings me to the next step, to the controller classes. And let me just double check with which controller we want to start. Yeah, let's start with the brand controller to keep it more easier. So there are two brand controller interfaces, I would say. So one is the get interface to return all the brands, and another one is a post for inserting a brand. And yeah, let's fill this with some business logic. This one should be quite easy because of we have the DB class as a static class. We can call it directly like this. So let's say db.root.getBrands. That's all we need. It is quite simple. For those of you who injected the DB, you would add here something like inject like this. Then you would inject the DB class, and then you could also use it. But we have the static way that enables us to call this directly this way. Okay, that was easy. Let's move on to the next step, how to insert a brand. There are also several ways to insert it, especially here. Some of you might say, okay, we could use a set instead of a list. That's also interesting. Regarding the question how to use unique object, for example, the set would grant us the possibility having unique brands in it. So we do not have to take care about if there is a brand like BMW is already available or not. But for my part here, I just used a list. So it is possible having two objects for BMW in it. And this is also the reason why we have to take care about the insert here. So that means whenever we want to insert a brand, we have to double check if this brand is already available or not. And that brings me to the first line, and I will just copy paste this. This is also a small hint to how to stream through the data or how to get the data out of an EclipseStore storage. Most of the time we're using the Java Streams API, and this is exactly what happens here. So let me just, this is not, oh, come on, what happened here? So, okay, I see. Okay, no worries. So we need optional, we need to import the optional here. And you see, this is the normal stream API. So we stream through the brands, and they say filter for a specific brand, and then we say brand.getName equals ignore case DTO get name. So the DTO get name is here, the brand, and find first. We use the find first at the end. So, and after that, we have to check that optional here. We have to say if optional is present. I think that's normal Java stuff. We have to create a new brand. And let me just do that directly like this. So let's say, let's create a new brand. And then we say brands dot set name DTO dot get name. So DTO stands for data transfer object. Okay, that's the easy task. We created the brand. If it's not present, that's important. So we create a new one. And after that, yeah, is empty. Is empty will not work in that case because we're having here an optional. So that means this statement returns a single brand or an option of a brand, and that enables me to say, okay, if this option is present, that's a specific way how to check this. If the optional is empty or is present, then I know, okay, it returns something or not. So it's because of the optional, but it's also possible having returning a list from that statement and saying, okay, is it empty or not? That will also work. It depends on you. Okay, so now we created the brand here, and we have to store that brand. And storing things in EclipseStore is quite easy. So we need a db.root. So we need access to our root object. And then we access the brands. So db.root get brands. And then we add the new created brand, just like always. So we created a brand, we added to the list here of brands. And next step would be storing stuff. So db.storagemanager.store. And this is now that step is an important step. And it's for me, it's incredibly important to mention that because this is also one of the most existing errors or mistakes by handling EclipseStore. It's always the question what to store at the end. And in EclipseStore, it's important to store the object which has changed. And that's exactly the point. At that moment, we add the brand to that collection here of brands. We change the collection. And that is also the reason why we have to store the collection itself. So that means when we call the store manager, when we call the store method, we store db.root.get brands, because that's the object that has changed. And there is another definition which explains what to store is you always have to store the reference holder. So that means when we create a brand reference here, a brand object and a brand reference, then the brand collection holds the reference to that brand. And that's the reason why we have to store the list itself. Okay, so we have to return something. Let's call return, and let's return an HTTP response. Let's say, oh, let's say okay, and let's return the brand. Okay, so that's it for the brand controller. And again, you could implement this in 1,000 different ways. It's just for me to keep it as simple as possible and make it more understandable, the basics of EclipseStore. Yes, Uwe, I guess I answered that question, or is there still a question on your side? Maybe just to explain the DTO here, it's I think it makes always sense having that transfer objects to communicate in between the different REST interfaces, and not sending the entities itself. That makes mostly sense, I would say, and that's why I use that brand DTO. Okay, and yeah, the point is, I did it exactly wrong here. You are right. I used the entity here, but normally I would use a specific DTO object. I use the brand here to make it more easier. I think that's why you mentioned that. Okay, let's move on. Brand controller, it's done. If there are any questions, just interrupt me. So let me know if there is something unclear. Car controller, a little bit bigger one, but I need to cover all the different situation, inserting, updating stuff. So list cars. So it's that is straightforward, right? So we call db.root, it's always the same, get cars. That's it. Nothing more is needed here. We already talked about this. Next one, by model. Let's find a specific car by its model. And the model is a string. Let's double check within the car. It's also just a string here. That should be an easy task to find the right model. So it starts with the same db.root.getCars.stream. And let me just check if I am on track. So we use the filter dot filter. Let's say car dot get model dot equals ignore case, then model, and after that I call the collect. So am I right? Dot, oh, what's wrong? So dot, now we are. And collectors dot to list. Okay, here we are. So again, we're using the Java Streams API for filtering a car, a specific, or for filtering for a specific model. And that's how we're looking for all the cars where the model is equal ignore case, the model that we hand over here. And after that, we collect a list at the end. And we directly return this. And there is the next step is mostly the same. So that's why I'm copying by brand. It's the same. It's the same here. db.root get cars stream filter. So let me divide this a little bit. Car.get brand get name. I think that's the only difference here. We calling car, then give me the brand, give me the name, and then it's the same equals ignore brand equals ignore case of brand here, and it's the same collectors to list, just to make it more readable. Having that here, quite easy. Clear cars, how to delete cars. And in that specific case, it means that we want to clear everything. So deleting all the cars of the collection. And that's also really straightforward. First step is we need to clear the collection itself. So let's say db.root getCars.clear. So for clearing the collection itself. After that, we have to store the cleared collection. Storage manager.store. And remember, we're storing the object which has changed. And in that case, it's the collection of cars that has changed because we cleared it. So we have to store it. And last but not least, we are returning an HTTP response. Let's say cars cleared successfully. That's it. And last but not least, the insert of a specific car. And this is quite similar to inserting a specific brand. First, we have to check if the brand which is part of the data transfer object here, if that branch is already available. So we already talked about this. It's the same like before. And if the optional brand is available or is present, could use it. So then we say, okay, brand, optional brand dot get. So that's two. Okay. Yeah, I missed something, but not that important. Okay, so we have to create a car, of course. So let's create a new one. Let's say car dot set brand, which is the brand. And in that case, in that specific case, the brand has to be available. Otherwise, it will not be possible to storing a car. So the brand has to be in the system. That's what we have here now. It's just an example. Car set model, transfer object, get model. So the car is created. And after that, to store it, root dot get cars dot add car. And then we have to store it. Let's say db dot storage manager dot store get cars, because we have changed the cars collection, and the cars collection is reference holder of the new created car, and that's why we have to store the cars collection. And then we say return car. That's it. So again, there are 1,000 different possibilities how to create, and I'm pretty sure there is a lot of stuff that is still missing here to implement. What happens if the brand is new? We have to add the brand and so on. I think that's not important for that example. It's just to give you an idea how Eclipse Store basically works and how to using all the CRUD functionality, deleting something, entering something, updating something. That's for sure. Maybe I missed an update, but we will talk about an update a little bit later. Okay, so that's it so far. So we implemented most of the functions that we need. And as always, let me just close everything, and I will move to the next branch, just to make sure that everything is nice coded, of course. You know, live coding is always quite a mess, so it's much easier for me to switch. But in the end, the implementation is the same. You see that here. And let me start the application. And we have to be careful at the moment you start the application, the data folder is created here. So always take care about if that data folder is already available or not. And there is another second hint I want to give you. When you want to start a Micronaut project like this, just move to the application class, and then you could easily say run as Java application. I think in other IDEs it's a little bit different, but one important thing is you have to activate your annotation processing within your IDE. So especially for Eclipse, you will find the annotation processing within the Maven section. There is annotation processing, and in my case, it's on experimental. It could also be on automatical. That's not that important, but it has to be turned on. So you will need annotation processing also on IntelliJ. I think that the options are quite similar to Eclipse, and you have to activate this. Otherwise, it will not run. So in my case, I do a Maven update just to be sure that everything runs nice and smoothly. Okay, so and now run. So when you run, you should see the following stuff in your console. And in my case, it runs on 8070 on that port. And let's do this. Just remember 8070 slash, and let's jump back to the controller class. And let's check for cars. And that means localhost 8070 and cars. You see, the first thing that gives you an idea that everything runs correct is when EclipseStore is initialized. That means at that moment, we accessing this interface here. The DB class will be initialized. That's why it is a static one. And let me just switch back to the browser. And when we call this at the end, you will get an empty result because there is no data available. And yeah, it's unfortunately it's not an easy task to create. That's why I having my postman here, just to give you an idea. I created all the different interfaces here just to create some brands and create some models. And that's what I want to do now. So car exercise, let's add a specific brand. So let's insert a brand. So yeah, I created it here. So it's a post and oh, come on. So let's create a Ford. Wrong port here. So 8070 brands insert. So we will get a 200. Okay. Let's create a BMW. And let's do another one. Yeah, let's say Mercedes, whatever. So, okay, so let's list all the brands. I have to change the port. And here we are. These are our brands. Let's restart the application to prove that everything is stored. Let's start it again. Just to make sure everything is. So you see that EclipseStore is initialized again. And when we click on send, we will get the result. These are the three created brands here. And based on these brands, we are able to create some cars. So insert a car. Yeah, let's create a BMW, an M5, and send this. Oh, I have to change the port. Okay, created. Let's say M3. And when we now call all cars, we should get the result of these two created cars at the end. So where is the data persistent? That's a good question. So when we now jump back to the application itself, you will see that there is a data folder created directly within the project. The reason for that is that we just write it data here. So that means the data itself and the storage itself, it's directly on your hard disk within that folder data within your project. This is not by far not the best practice way storing data within your project, but you would say, okay, let's put it on your persistent volume claim of your Docker container or whatever, of your Kubernetes container, whatever file path you could store, you could enter it here. And the storage looks exactly like this. So there is two channels. That's the reason why we set it here. We wanted to have two channels, and channel 0 and channel 1. And there is the persistent type dictionary, which contains all the different object types and so on. And that is where the data is stored. So that means it's on the hard disk. And this is, by the way, the most common way storing the data directly on your hard disk, because it's quite close to the application. And yeah, but it's also possible to have it on S3 bucket, for example. That's totally up to you. Yeah, on your needs, on your requirements. Okay, some more questions. So we are done with the exercise at the beginning. So it took us around 40 minutes, but this is okay, just to go through all the basics and go further with some additional advanced topics at the end. Any questions from your side? Could multiple instances read and write to that data? To be honest, no. There is only one JVM that could access that data folder at the same time. And I have to say this is a little bit on purpose, because it's I think when we talk about let's have a short look to a relational database. You all know that we are used to access a relational database from multiple applications and from multiple different applications, and that is the way how it works for now. But nobody would recommend this. Everyone will tell you, oh, don't do this, different business logic, touching your data, and that is not the recommended way to do. Just create one application that accesses the data and provides the data via REST. And this is the same on EclipseStore, and the same recommendation on our side. Just let one JVM access the data and provide the data to all the other guys or to all the other consumers via REST. That's how it should work. And this will also, by the way, when you try to access the data with two JVMs, that could destroy the storage. That's I will come to that a little bit later, because there is a locking mechanisms in the background, but you should not do this. Okay, but good question, definitely. Okay, so let's move on. Let's talk about our next topic, and it is, let me just double check, configuration advanced. I prepared a small presentation to give you the basic informations regarding configuration, and we will have a short look also to the documentation of EclipseStore. What can be configured, or what settings are you able to do? So first of all, storage naming. That is really straightforward. You could renaming everything, create or adding some prefixes and suffixes of the files on your hard disk. You could change your channel names and so on. For whatever reason you want to change this, this is possible. Storage naming. You will see a huge list of things that could be changed on EclipseStore, and it's totally up to you. One of the most interesting things are the channel count, for example, or the backup directory. That could be interesting. A backup file system, whatever else. And you will find all that stuff directly within the documentation. And with some of the most popular configurations I want to talk about now. So the first thing is the channels. I'm not sure if Florian last week already mentioned this, what the channels are. When we talk about storing data or writing down data to the hard disk, this could happen in a multi-threaded way. But to have this multi-threaded, we need multiple channels to write down data in parallel, and that's the reason for channels. In our experience, it's okay having something between 1 and 4 channels. It also has to be power of 2, so you could have 1 channel, 2, 4, 8, and 16, and so on. And the more channels you have, the faster you could write down data to your hard disk. So that means when you writing down data, which, let's say binary data, for example, images or whatever, then it makes sense having more channels storing that data in parallel, because it will be faster in the end. But you always have to consider that when you load data and you have a huge amount of channels, let's say 16 or 32 or whatever, then it takes you longer to load the data. In some parts, this is not really, let's say, this is not really a problem, because most of the data is in memory anyway. So that means whenever you call the data, you mostly call the data from the RAM. So it's not necessary to load it all the time from the hard disk. But in some cases, a huge amount of channels will decrease the loading performance. But so that's why I say it's a sweet spot I would recommend is something between 1 and 4, and that is enough for most of your cases, I would say. Yeah, that's the stuff I've talked about. Segmenting the YIP. So as I said, a sweet spot between 1 and 8. Yeah, to be honest, 4 is totally enough. Maybe there are situations that 8 or 16 is okay, but I've never used this before. So the way how to set this is one example using an XML file to doing that stuff. We will talk about this a little bit later. And this cannot be changed the easy way. I also cover this a little bit later, how to change the amount of channels. Okay, so we do not need this. Housekeeping, I will skip this because this is a topic for advanced 2 training. Just a small hint for the housekeeping. Because of EclipseStore is a technology that attaches the data again and again. That means whenever you change something or you update something, the same object which has stored or which is stored at the end will be attached to the end of the storage. That means you will get duplicates. The more the storage or the more update or storing calls you have, the more are these duplicates are growing. And the housekeeping process is a process that deletes those duplicates and cleans the storage at the end. And sometimes in some system, it's necessary to increase the CPU and memory requirements for that housekeeping process to decrease the storage size, especially when you have, for example, high frequent data writing to EclipseStore. Okay, but this is a part for advanced 2. I will also bring an example then. Backup configuration is also a topic for today, but a little bit later. A A read-only manager is available, but it's not part in the training so far because it's there, but it's still work in progress, and it's not really necessary to have that. Okay, let's jump in. So I again prepared a project for you, and the first project that I want to show you is the way how to change the channel size. So and that's why I prepared a project which is called channel migration. And it's not only channel migration, it's migration, all over migration, let's say. Let me just double check with what branch I'm in. So channel migration main, that looks good. Okay, let me just check if there are some questions. Okay, there is one question from Uwe. Yeah, we will talk about lazy loading and how much data will stay in the RAM. We will do that later when it comes to the lazy part. Okay, so is it possible to reduce the channel later on? Yes, it is. That's what we are working now, exactly. Okay, so let's move on. Channel migration. So let's double check the settings. And you see, so we have the channel count here, and there is no storage path. So I guess EclipseStore will use a storage folder directly within the project. So let's check this at that moment when we start it. So channel migration, book controller, there is no storage available. Let me. Okay, no, it's empty. So let's start it. So run as, and during the startup, let me share this with you. Channel migration, here we are. Here is the link to the project. There is only one branch in it. Yeah, there is only the main branch. So you see, application is up and running. So let me call the local host 8080. 8080/books. No book controller. Setup data. So localhost not found. What's going on here? Okay, there is no. Okay, I see. So let's call this books/setup data. And I improved the controller a little bit, so that enables you to use the browser itself to call the REST endpoints. So that means most of the endpoints are GET endpoints, and that enables you to use the browser to call it. So that means localhost 8080, then we call books here, and then setup data. So let's enter this, and then we get an error message. So what's the problem here? Okay, maybe let me refresh that and do a Maven update. Okay, so application start again. Yes, books setup data. Come on. What does it says here? Serializer. Maybe it's because of the project update. Yeah, that's why. So I missed the version on storage embedded. So yeah, let me just push this directly after. So team. Come, so update. Okay, now it should work. Okay, so now it works. So EclipseStore started. So and there is another endpoint within the controller, which is called give me all books with the ISBN 1. So let's call this books ISBN with 1. Now you see these are all the books that are created at that moment when we called the setup data. And the reason why this works is I created some mock-up utils here within that project, and there are some authors and books here, some JSON files, and as far as I know, there are around 1,000 books and some further authors at the end. And it is created at that moment. You call that a setup data. And here we have now the data created. Yeah, as I said, around 1,000 books with name, release date, author, price, and so on, just to play around a little bit with data. So, okay, so data is created and available. And when we now look at the project itself, we will see when we call refresh, now you see there is one folder which is created, it's called storage. And as I said, and as we configured it, there are 2 channels. And let's jump into the DB class. Now you see that there are two channels, and that's the only thing which is configured, and it's created here too. So, and now the question was, how is it possible to change that? We will not be able to change that the easy way. Just do it like this, creating, let's say, 4. This will not work because EclipseStore will look for 4 channels at the end, and that will lead to an error message. So that means we have to migrate the storage a little bit. And therefore, we created a function that a storage migrator, I would call it. And it's not only for changing the channel count, it's made for many different situations. And 2 of that situation I will mention here. So this is the source configuration. So that means that's the configuration which is used currently. So that means we have a set channel count 2, and we have a storage which is called a storage directory which is called storage. And we want to migrate the storage to channel count 4, and in addition, we want to have it on a different place. So let's say set storage directory, and let's call the storage directory DB. So that means we have a source configuration, and after that a target configuration. And this is just for knowing what's going on. And then we use the storage converter here to convert the source to the target, and the start method starts the conversion at the end. I added this in just a main directory, or a main method, so I have to say, and that enables me to start it directly, and this transfers the storage. And when we now refresh the project, you will see a second storage is created. It's the DB storage with that 4 channel count, and the storage one, it's the old one. And now when we now start the application again, of course we have to change the configuration a little bit. So because now we want to use the new created storage, and that also leads us to changing the values here, the initialization of the storage. So we have to say set storage directory, and now we have to use DB instead of storage, the default one. Okay, so let's try it out. Let's start with a new configuration. You see it's up and running. And now we should see the same result when we call it. And you see, here's the data. So that's exactly the data we stored. So that means Eclipse Store creates a copy of the whole storage and stores it to the new folder. Why is that like this? Or why do we need such migration tools at the end? The reason is sometimes the structure is a little bit different. For example, when you have, let's say, you're working with a storage which is created on your hard disk or persistent volume, and you want to change that and you want to move the storage to an AWS S3 bucket, for example. And then the structure of the storage within an AWS S3 bucket is a little bit different to the structure on your hard disk. And this is, for example, one possibility to migrate your existing storage to an AWS one, for example. And that's the reason why such migration tool is implemented. And there are many, many more possibilities changing stuff from storage naming, storage directory, channel counts, and many other things are covered within that storage converter, and that enables you to change things within your storage. Is it possible to migrate with the same storage name? Yeah, it's also possible. So let's give it a try. So let me just stop this and let's remove this. So that means we want to stay within storage itself, but we want to have it at the end with just 4 channels. That's also possible. So when we now click on refresh, we should see that additional channels are created. So you see that works great or worked great. I would say it transfers or it splits up the data to 4 channels. I think that's good to know that this migration stuff is available because it's not that easy to change it the manual way. And sometimes it's also necessary to use that migration tool for some version upgrade. So for example, when we upgraded from EclipseStore 1 to EclipseStore 2, it was necessary to use that migration tool at the end. Yeah, the other way around, it's working the same way. So let's do this. So we have 4 storage and we want to have 2 again. Now we say refresh. Okay, yeah, I think let's give it a try. Let's delete the channels here because they are no longer needed, and let's start it. That's interesting. So we have only 2, and we don't need this anymore, right? So that's interesting. So it starts up. That's a good. Let's wait. Okay, there is an error. Okay. Yeah, okay, there is a problem in channel 0. It seems that this did not work properly. So let me just check if maybe we could use the DB one. So 4 and it's in DB and we want to have it to 2 in. So, and let's call this storage. So fingers crossed. So the storage is created with 2 channels. That looks good. So yeah, channels 2. So give it a try to start up. Here we go. Yeah, here's the data. So yeah, when you migrate down sizing, you have to downsize this to a new storage. I think it's because of some writing restriction to the different channel files, I could imagine. But yeah, it makes sense having this. And it would make sense also for backupping stuff to always create a new storage. Otherwise, you would destroy your current existing storage. For sure, you will have a backup anyway, but it makes sense having this. But it was a good test, so it's okay. So any questions from your side regarding that storage migration tool? There are some more documentation within the GitHub repository on the API documentation regarding that storing migration or storage migration. But I think it's important to know that this migration is available and how to change the channel sizes here. Okay, channel migration. Check. So then let's move on to another project I prepared to give you an idea what possibilities do we have to initialize different storages. And I created a project again, which is called configuration. Just a second. Stories. Here we are. Let's copy the link for you. That's the project. Feel free to check it out. There is one. So normally I do this within a training. So so that means I let you implement this, but for today it's okay. Directly going through that. And so there is one. Here we are. So just close this. No longer needed. And let me start at the branch named configuration properties and file names. So that's the branch we want to start. And that's the first project. I did the mistake here because of, yeah, maybe this will work anyway, but it's not initialized the right way because I used the Micronaut way to initialize it without the static stuff. You see that here, but at the end, this will lead to a non-used root object. It's not a big problem for our example, but I have to improve this because at the end, when we restart a project, the root object will be empty. I think it doesn't matter for the project itself because we could see how the different initializations work. And let's get into it. So give me just a second to clean up this a little bit. So I need my... Okay, so here we are. So many different ways to initialize and configure a project or a storage. And it's also great to see that it's possible having multiple storage manager within one project. And you could also have multiple data routes. That's mostly also a question from some of you. Is it possible having multiple routes at the end? Is it possible to have multiple storage manager? And yes, it is. It's not possible having multiple routes in one storage manager, but you could have as many storage manager as you want within one project. So that could also cover some situation, maybe for client capabilities of an application. It makes sense having multiple storages. It's totally up to you designing that. And let's start with a short way to initialize your storage manager. So the shortest way I know is, and let's use the storage manager number 1 for this equals, and there is one call embedded storage dot start. And within that start method, I could hand over the two elements. The two important most elements is root1, which is the root object. And if I want to add a path, it could look like this. Let's call it path dot get path, sorry. So dot get. And then we could add some, let's call it short storage. So that's quite an easy, short way to initialize an embedded storage with a root object and one possibility. And for this, especially for this, it's not needed to having that configuration package or dependency. It's just, you will just need the main storage embedded dependency. So another way to initialize is using an XML file. And I just copy paste this, make it a little bit easier. I just need this one, yes. So because this is Micronaut stuff for loading a resource, and in that case, it's a MicroStream or EclipseStore XML file. It doesn't matter. It's located down here. And that XML files contains multiple different configurations like the storage directory, the channel count, directory prefix, and so on. So that's one possibility, having that within an XML file. And that XML file is loaded here and as a resource. And based on that resource, I embedded storage configuration load here, resource.get path. And as always, based on that configuration, I create the foundation. And based on the foundation, I create the embedded storage manager with a root object. And that's it. So another possibility using XML to initialize. Next step is the builder pattern. We already used the builder pattern. And it's, in my opinion, it's one of the most recommended way, I would say, because that enables you using environment variables, for example, for initializing your storage. And this happened here. So especially here, I draw out I pull out, how to say, the environment variables that are part of the application.yaml file. So you see that here that is the YAML file and of the Micronaut application, and there are some. So let's say the path is db, the backup path is db_backup, and channels are 2. And with the add value annotation, I pull out the values and put it to the path, backup, and channel. And these things are reused here in the builder pattern here. And let's say set storage directory path, the backup directory path, and so on. And yeah, this is another way how to initialize. We already used this builder pattern, and in my opinion, the most recommended way. Except a specific integration for Helidon or Micronaut. If you use the integration of EclipseStore, this will look different. So, and last but not least, in my opinion, the most complicated way to initialize, but on the other hand, the most powerful way to initialize is to use the API, the direct API itself. The structure is the same, I have to say, but this enables you to adjust everything on the different layers. So we start, as always, with a configuration, and this allows you to do some really fine adjustments on the storage itself. And based on that, you create the foundation. So let me just check, where is it? Create configuration, and there must be a foundation also somewhere. Okay, here is the foundation itself. So it starts on the foundation, and it creates the configuration within. And then at the end, we could say, okay, create embedded storage manager, start. And there are some points, especially when we want to have, maybe it's here. Yeah, for example, when we have a special file provider, like an AWS provider, for example, then we need a specific foundation here. But I'm not sure. In some versions, I think we improved the builder pattern, and now you will be able also to adjust most of the settings also with the builder pattern. So we will check that later. But this also works, and these are the 3 or 4 possibilities to initialize EclipseStore. All these 3 or 4 opportunities are covered within the documentation, so feel free to read it there and to review it there. And let me just start this, just to prove that this will work. So application here. And so you see all the different applications and storages are starting up directly on startup. That's why I created that application startup provider here, which is already available here. And you see that db.initialize builder storage, initialize foundation storage, short storage, and XML storage. And that leads us to the point that here all the different storages are now created. You see that here. There is which one? This is the data one. DB, this is a backup one. We will talk about this a little later. The foundation one and the short one. So all these storages are created on startup. So, and I think it's nice to see that it's possible having multiple storages within one project. And on top of that, you have it gives you an idea what are the different opportunities for creating a storage. And I just have to check this. Yeah, it makes sense to have that here. I want to add something, something that I found really interesting. We talked about that locking stuff. So and accessing storages from different JVMs, and they, especially when you use Kubernetes, for example, then there might be some situation where Kubernetes creates a second container that claims the persistent volume, for example, and tries to connect to the storage. This is an automatic feature that exists in Kubernetes, and that's one situation that makes it necessary to activate the locking mechanism. So there is a mechanism built in that restricts the access to a already running storage by a second JVM. And it's covered within the documentation here. And when we have a short look to the configuration, you will find that log file here. And by default, it's not necessary to have this, especially when you're not using Kubernetes or stuff like this, then you will not need this. It's just a security mechanism to prevent accessing one storage from multiple JVMs. And this is the only thing you need to do. So you have to say set log file setup provider. So this is just one line of code. And you see that here in that moment we write it that documentation, it's a setting based on the foundation, but it should be also available now on the builder pattern, I guess. So when we jump to the builder pattern here, so it should be possible doing this directly here. .set log. Let me just log file setup provider. Oh, maybe it's based on the on the foundation here. So dot set. Yeah, here it is. So we just could copy paste that set log file setup provider here. And this prevents, there is a timer in the background. And so that means when a second JVM tries to claim the volume and claim the storage, it checks for about 5 minutes, or it waits for a specific time to attach the storage at the end. So if after it is released from the first one. That's interesting to see that. For some further information, just feel free to study the documentation here and the API. But I think it's interesting to know that a functionality like this is available. Okay, any questions so far? There's a lot of stuff. But I think most of you would prefer this way to initialize, and that's okay. Sometimes it's interesting to know that some different solutions are available. And I think everything should be already implemented within the last branch. Configurations done. So continue. Yeah, now I'm on the configuration done branch, and you see everything is already in place. Just for you have this as a kind of documentation at the end. And also the log file provider is also there. Okay, so any questions from your side? Okay, so we are right in time. Let me clean up this a little bit. So I brought you two further projects, and I like to mostly share this with you because there are opportunities for using this. The first project is a project that I created for, I would call it a proper Micronaut setup. I used the Micronaut integration to use EclipseStore. Just a second. So we are. Okay, so here we are. So that's a project I set up for giving you an idea how to use EclipseStore within a Micronaut project. And you see there is a lot of stuff going on, and I separated all the different classes. And by the way, there is also a Lucene integration here. We will come to this a little bit later when we talk about lazy loading. But I think it's interesting to see how this works. This is kind of like a default implementation with Lucene in it, and there is also a read-write locked thing. By the way, there is a new implementation of the read-write locked available, but that is part for advanced 2 training. And till that training, I will update the project for the new one. Okay, but so you will not find any DB class anymore. There is no DB class or initialization of the storage. Everything is behind the scenes. I have to say, you just have to add some specific properties here, just to add the root class. And this is the storage directory, the path where the storage is created. And that's all you have to do. And in the background, the DB class is created and the embedded storage manager is created. And you just have to inject that stuff, for example, in the DAO objects. So where are the DAOs? So the domain objects are here, really straightforward, nothing special. books and so on. And there it's the data transfer objects. So where are the DAO objects? Here, there's only one. So now you see that here, that's the root provider, which is injected. And it's in the same way then the manager is injected here. And you will not need to initialize all that stuff the static way. It's created in the background automatically. And you just have to inject this. And then it could be used within your DAO classes, for example. It's in a way, it's much easier to handle and to use. But all over, I think it's interesting to see how this could work with a proper integration. And last but not least, another project which could be interesting for you is how to store data to an AWS S3 bucket, for example. It's this project, and it's also here. Everything is implemented within the master branch. And that's a project I created in a normal way. So that means there is a DB class used the static way. And it's I think it's mostly based on the blob storage file system here. So that's the important stuff. So what you have to do is there is one class I created, which is called S3 utils, to create an S3 client. So let's jump into this. So that's the client. One important thing is you have to provide the AWS access key and the secret access key via an environment variable. This is happen in the background. So when I start a project, I use these environments here. And let me just show you the bucket itself. It could be interesting. So this is the bucket here that I created. And let's delete the bucket here. So let's say delete those objects here we do not need. So, okay, so bucket is empty. And the bucket itself, or the folder within the bucket, so I have to say, is available here. And it's configured within the DB class. See, this is the name of the folder within the bucket. And when we now start the application, it's really straightforward with author and books. It works in the same way like all the other applications we talked about. So, and let's start it. And now I have to choose, just a second. Let's here, I have to move yeah, okay, so this should be the right start. Okay, localhost 8080. So let's open the browser. Let's call books.create. That's what happened now. So the storage is initialized. And you mentioned that it took us longer than expected to start it because all the data which is created by the mockup classes. So as I already explained, these 1,000 books and authors are created in the background. And now this data has to be pushed to the S3 bucket. And now it's done. So when we now have a look to the S3, so you see that the structure is created. So now channel 0 and persistence type dictionary is created like in the same way that we have that on the hard disk. And when we now call so data is created, and let's see, here are the books. So people mostly ask me, okay, what makes more sense, having data on S3 bucket or on a persistent volume or a hard disk or whatever? So in my opinion, it's I think it's quite similar because the performance based on the in-memory data is the same, no matter if you have the data on a hard disk or on AWS S3 bucket, because the data is in memory anyway. So whenever you access the data, it comes directly from your RAM. So it's in the same way thing. When you have a lot of lazy data within your storage, then it takes longer to transfer the data from an S3 bucket than from your hard disk. So I think that's clear. And that's the only difference, I have to say. So that means when you have a lot of lazy data, then I would prefer having that on a persistent volume because it loads definitely faster than from an AWS S3 bucket. If you have no lazy data, it makes no difference having that on S3 bucket or having that on a remote storage. So I have to say, because it's in memory anyway. But I think it's important to see how the configuration is. And let me jump back to this. It's all based on a file system. And that file system is used at the end here. So embedded storage.start. And then you could hand over that file system, and that's it. It's not really a big deal. And you will see a project later on, which is a combination of storing the data on the persistent volume. So the main storage is locally, but the backup will be written to an AWS S3 bucket. So there is also a project I prepared for you. Okay, so any questions regarding this example here? I think all over, that's it for all the different configuration stuff and setting stuff. I think there's a lot more to explain regarding settings and how to use them, but I think most of the important stuff is covered within the Advanced 1 training. There are some smaller topics on Advanced 2, but the major part is done here. I think I shared all the project with you, and now it's time for your questions. How about cloud storage like High Drive? High Drive is from Hetzner, right? So this is the S3 from the S3 pendant of Hetzner, right? So as far as I know, it's not usable so far. But it's a feature on our list. That's I can say. Yeah, it needs time. So the feature is in the list, but it's not available now. But I'm pretty sure having an implementation for that will not take that much effort because they are quite similar to each other. I think yeah, maybe if we are lucky. So EclipseStore MicroStream is an open source project, so it's on you to create an interface to that. And yeah, as I said, I'm pretty sure it's easier to implement because it's working the same way like AWS S3. And maybe some of you are interested in implementing an iDrive interface. Okay. One question, is the application still responsive and we can work with the data while persisting a lot of data to save over the network? An interesting question. So let's say the storing data is a blocking request. So when you transfer the data to a S3 bucket, this is a blocking request. But it's on you having that on a separated thread, for example. So that it's totally on you using the normal Java mechanisms to make it non-blocking, I have to say. Yeah, that's why it depends on your implementation. On the other hand, when we talk about having the data directly, so you always have to keep in mind that when you adding something like we do, so let's say let's give me the list of cars, for example, and you add a car. This car will be immediately available for everyone or for every session on your application, because every session is working on the same object graph. And that's how it works. So when we're talking about the Micronaut application, for example, then we will have different sessions, but all these sessions are accessing the same object graph. That's why it is more important to take care about concurrency with EclipseStore. That's why there is a topic on the Advanced 2 training. But everything you add to the graph will be available for everyone, and storing that, it's up to you, adding this to a specific or to an additional thread or whatever. But basically, you are right. The storing something is a blocking operation and takes a lot more time sending data to AWS, of course. Yeah. Yeah, of course. There is also Spring Boot support, and there is, as Marcus mentioned a little bit earlier, there is, let me just jump to this. Marcus already explained that at the beginning of the training. There is a CDI integration also for Spring Boot, and we are using Micronaut also. And when we have a short look to the documentation, it should be also available there. So give me just a second. Sometimes it's hard to find. Yeah, here we are. So when you could have a look to Spring Boot, and here you will find this under integrations, and there is a Spring Boot integration. And yeah, it's up to date, as you can see it here, and feel free to use this. And in my opinion, it works the same way than in Micronaut. So feel free to use it. Okay, so we already talked about concurrent access of different sessions and users and so on, and everything is working on the same object graph. And that leads us to the next topic, the topic transactions and exception handling and stuff like this. And we need to have a more detailed look to how to store data, how to roll back data, how to create a transaction within Java. And that's why I want to start with a small presentation just to give you a short idea how the store mechanism work in the background. And to store a newly created object, we store the owner or we store the reference holder, and we already talked about this. And this is how it works, and you already knew this, and you've seen this before. And modifying an object works in the same way. So whenever you change something within, let's say, book set release, you call the db.storemanager.store. And whenever you call the method store here, you always use we call it lazy storer mechanism. And what does that mean? There are two store functionalities. The first one is the lazy storing functionality. And this is the default storing mode. That means whenever you call the store method, you're using that lazy storing mechanism. And that means that it only stores the changes of the object you hand over. So that means, I will give you an example. When you have a book object, for example, and that book object contains an author, and you make some changes on the author object, and after that you call the store method on the book, then these changes will not be stored. And to make it more clear, let's say we changed something on the book itself, and we change something on the underlying author, and we calling the store method, only the changes of the book will be stored, not the changes from the author. That means the lazy storing stores only the single object which is handovered without all the underlying sub-entities below that object. And there is a second store functionality. We call it eager storing. And eager storing does exactly the opposite of lazy storing. So that means whenever you call it, eager storing mechanism means it stores the object which is handovered to that method, and at the same time all the underlying stuff below. So that means the book will be stored, the author will be stored, and maybe an address below the author, and so on. The reason why lazy storing is the default mechanism is because of the fact that EclipseStore is an attaching storage. That means everything which has changed is attached to the end on the storage. And now you could imagine why eager storing would be a big issue if you use it all the time, because it could lead to attaching the whole storage again and again at the end. So let's imagine you call eager storing on the root object, for example. That means EclipseStore will attach the whole root object again and again at the end of the storage, and that will be big performance issues at the end. And also the storage on your hard disk will increase and decrease, and this is not the way we want. But we need that eager storing mechanisms. Also, there are situations that that requires an eager storing functionality, but you should, as long as it's possible, always stay at the lazy storing stuff. But the question is how to use this. And I think that brings me to the example that I want to share with you. There is one project which is called, just a second, it's called, is it exception handling? Yeah, I guess this should be the right one. So let me just share this with you. Okay, so link incoming, exception handling. This project contains multiple branches, and let me just check which branch do we want to start with. Yeah, let's start directly on the master branch. That's totally okay. So I will do a little bit of coding here. So let's go through that project. It's really straightforward. We have our DB class and so on. There is a book controller here, and some of the methods are already implemented. So as I said, the create book is still in place, and also get book and clear books and so on. Everything is in place, but except the update multi-books. And this is the point where we want to start, and where we want to talk about a little bit how to implement stuff like this. So we talked about stream filter. Let me just order that a little bit. Okay, so what happened here? So the reason for that interface is we want to update multiple books, and especially here we want to load every book that starts that title starts with an A, and we want to update every book that starts with an A. Whatever changes we want to do, the question is, how could this work? So all that books are within that collect here. And now we could say, okay, so let's do so. So let's stream through these books. Let's say, we could do it this way. So let's say collect for each. Let's add B for each book. And then now we say B dot set what could we do? Set price, and we say new big decimal, let's say 50, right? So let's change the price of each book that starts with an A to a new price, and let's set it to 50. Okay, so now we changed it. Now we need to store it, right? So how could we do this? So we could do it this way. So we go to our DB, storage manager, dot store, and then we say B. Okay, so we changed the book is the reference holder of the big decimal price. So to storing B is totally the right way. But the question is if this is the right way to do this. So we already talked about this. Every store is a blocking operation. So that means this will decrease the performance of my for each okay, this will decrease the performance a lot. Let's say it like this. Okay, so how could we change this? There is one possibility to create a special storer. So when we call db.store storage manager create an eager or a lazy storer. So that enables us to create a specific storer for a special situation. And in my situation, creating a lazy storer is totally okay because I just want to change something which is directly within book itself. So it's not necessary storing some underlying or entities below a specific book. It's a direct storing here. So we create the lazy storer and let's call it ls. And now that enables us to say, okay, instead of storing each change, so we could register the book which has changed to our lazy storer. So now we could say ls.store b. So, and sometimes that is a little bit confusing, that store method here, but it tells you, okay, b, so book is registered for storing, right? So, and after that, when everything is fine, we could call ls.commit. And that brings us, and when we call that commit method, all the changes will be stored at once. And that's the moment that having this way, then the whole storing mechanism becomes more transactional, I would say. So we are able to register a book, and after that, so that means there is only one store or one action, one blocking action for storing all these changes. Okay, any questions so far? And we could do, by the way, we could do the same with an eager storer. It works the same way. We could call it ES, and ES will work the same than the lazy storer, but with the disadvantage that every entity below book will also be stored, and this is quite an overhead. So, and this is the reason why we do not need this. So lazy storer is totally okay for us. Okay, so any questions so far? That's great, right? It's not that difficult. It's creating a storer, use it. And as I said, the lazy storer is the default behavior. So whenever we call store, then lazy storer will be used. Okay, let's move a little bit further. So how could we use this within a rollback mechanism? And that brings me to the next step. And now we should change the branch to the next exception handling and switch to, not sure which one is the right one. Let's use this one first. Okay, so let me just check. So as I already mentioned, I did some changes. Yeah, but maybe this will work. So for controller. Okay, so in that branch, there are some improvements made on that controller. And this is, by the way, also how you should do this. Instead of storing stuff within your controller classes, you should have some DAO classes somewhere, data access object classes, and that takes care about update multiple books, for example. And here we searching for all books ISBN starts with 4 and 9, and then we hand over that result to a DAO class that takes care about updating stuff. And now we are jumping into this and then now we see, okay, so here it happens the same way. It creates an eager storer, and one special thing which could be seen here is the try catch here. So when we're talking about transactions and rollback, so we're using the normal Java mechanisms that provides Java to us for doing something if something went wrong during the process here. So that means whenever something goes wrong here, we're jumping into the stack trace or the exception part, and that enables us doing a rollback. And how the rollback works, that is part of the next branch. So that's the next step. Team switch to rollback implementation done. And now this looks like this. So just for yeah, okay. Just to give you an idea of how this works, to simulate an error, I would say, I created some methods that is update book non-store and update author non-store. That's just for creating changes within the RAM without storing them. So because otherwise I had to produce an error or whatever, and that's why I use it this way. When we now go to the update multibooks, this works the same way. And after this, so this is a default implementation, I would say. And there is a reloader here. And that reloader enables you to say, okay, reloader.new with the current storage manager. And you need the persistence manager out of that. And this reloader can be used for reloading flat or reloading deep. And flat and deep works in the same way than lazy and eager. So that means flat means only rollbacking the object itself, and reload deep means reloading everything also below that object with all sub-entities, I would say. And B is for each book. That means we are reloading every book and, let's say, updating the RAM from the current existing underlying storage from the hard disk. So, and just to give you an idea how this works, let's start that application. So we need that one. So just to double check if there is a storage. So let's do a Maven update first. Okay, there is no storage available so far. So let's start it. Okay, storage is up and running. There is a lower version of I'm currently working on updating each project, and it's still work in progress for that, but it's not really a big deal. So let me call 8080. There is one create books. So let's call localhost books/create. Okay, you see that books are created. And when we now load this, okay, that is the part of our storage. So, and now we are calling the method for changing something. Update multi. Okay, these are the things I want to call. So update book non-store. So let's do this. So slash update. Oh, what was the exact update book non-store? So name of book successfully changed from Start Chamber to Java the good parts. So let's check this. So see that it changes the name of the first book here from before the name was Start Chamber, I guess, to Java the good parts. And now you see the problem in this situation. Let's imagine you change the RAM, and after that, right after storing data, something goes wrong. Whatever could go wrong. So EclipseStore itself, it's really quite stable storage, because in between a persistent volume, for example, or in between your hard disk and the running application, there couldn't be a connection issue or stuff like this. I mean, it could be that a persistent volume is detached to the container or whatever, but these are really rare cases, I would say. So, and that's why EclipseStore itself, it's a quite stable running application. But for any reason, there could be the case that you change the RAM, but the store will not work. So then you will get an exception within your log file. But at the end, that leads to a running application, and the user will not notice that something happened in the background, because the RAM has changed, and also the data will look like normal, because the changes are in the RAM, but at the end it's not stored. Now imagine what happened when we work further on that. That leads to changes within the RAM. The storage will not work at the end. So that means the system looked like everything is normal and working great. But after a restart, you will notice that most of the data is missing at the end, and most of the changes are missing. And that's the reason why we have to take care about this. So, and this situation is simulated here. So that means we changed something. So the RAM is okay and looks like, okay, it works, but in the end, it's not stored. So let's restart this just to give you an idea. When we now reload it, you see it's a start chamber again. And that's exactly the situation after a restart. You will lose all your changes at the end. So let's call that update book non-store again. Update book non-store. Okay, and now we have the situation here. So, and now we are able to call the rollback flat mechanism. So let me just copy this. Slash rollback flat. And when we now see, you will now see it's the start chamber again. So let's jump into the code. And it's by the way, the same like rollback deep. So we could do this the same way. So let's say update. There is a second one. Update author non-store. Or non-store. Name of author successfully changed from Firks to Travolta. So check this. Yeah, you see that the last time is changed, and now we do the rollback. So, but instead of using rollback flat, we are using the rollback deep. And now you see that the last name is the same as before. So let's jump into the implementation. Rollback flat, rollback deep. Here we are. You see that you need to initialize a reloader. And with that reloader, that enables you to say reload flat. And this will revert all the changes within the RAM if something goes wrong. And in combination, to combine both with try and catch, this will look like this at the end. So you should always try to take care about reloading stuff if something goes wrong. Most of the time, to be honest, this is not needed, but for all the sensitive data you want to have, this will be necessary. Okay, any questions so far? There is one question from Gerd. No additional storage manager command necessary. I guess you mean these two lines, right? Or after this one. So no, there is no store needed anymore because you're reverting data within the RAM. That means you're reverting data to the stored version. So that means there is no store command necessary. You're just updating the RAM to the right version of the object. Okay. After the commit. Okay, no, there is no store command necessary. The commit itself is the store. So right at that moment, data goes to your hard disk. That's why I say sometimes it's a little bit confusing about committing and storing. That could be confusing, but yeah, in that case, ls.store is the registration, I would say, and commit is the store itself or the sending data to hard disk or to the persistent. Okay, and there is another question. There is no dirty checking of sorts, so that if I store object X, it is stored no matter if it was changed, right? Yes, yeah, it is exactly the point. So when you hand over, give it just a second, not sure. Maybe I have to double check this because when we have a short look to the documentation here, the description says that when we use the lazy storer, the object will not stored. But I have to check this. Storing, lazy, eager storing is the default are stored only if they have not been stored yet. That is sometimes a little bit confusing. That's if a reference instance has been stored previously, it is not stored again, even it has been modified. Yes, but yeah, I think I'm pretty sure about this. So when you call a store on an object with no changes, the object will be attached again. So I think that's the lazy and eager function behavior is only for underlying sub-entities, and therefore it's sometimes a little bit confusing. But when you call a store method, the object will be stored at the end. So no matter if there are changes or not. What is your recommendation if you have a deep data structure, e.g. a tree, and have many updates on several parts? I would always prefer the lazy storer because of the performance and yeah, try to sometimes uh, especially when we talking about a deep data structure, it makes sense for me to try to store only the things that have changed. So I would not recommend. So yeah, I mean it depends on the frequency of storing stuff. When we say okay, this happens once or twice or a day, that you have to store the whole, let's say, graph of an order, for example. Let's say you have an order with order details and companies in it and whatever else, then it's okay storing that with an eager functionality if this happens twice a day. So I think it depends a little bit on your business logic and um, yeah, I think there is no recommendation about that. It's on you how this works, how often you store this. But normally I would prefer the lazy storing stuff. Is there an integration with Jakarta transaction? That's a good question because does that I know that a colleague from me is writes an integration for Spring Data, and I'm not sure if this covers that situation. Is Jakarta transaction part of Spring Data? I'm not sure about this. But as far as I know, there is a Spring Data integration available on our GitHub. And you have to check this. The problem is, I have to say that Jakarta transaction mostly covers handling JPA and stuff like this. And the problem is Eclipse Store works totally different in some in in some in some situations, and that could lead to problems with standardized implementation like this. So it's the same on Spring Data. So writing the Spring Data integration for Eclipse Store was a really big issues at some points because the way how JPA and Hibernate and whatever else works is totally different than the Eclipse Store approach. Hopefully that answers it a little bit. Just give it a try. You know how Eclipse Store works on the basic layer. It's an open source project. Give it a try with Spring Data or with the Jakarta transaction. I think it's okay to check it out. So for you, whatever is possible, try it out. Okay, so some more questions regarding transactions and rollbacks and the API behind. Then I would move to the next, or one of the, I would say the major topic for today is lazy loading. And for lazy loading, I prepared another presentation to start with that topic. Okay, so lazy loading. What does it mean? The first question is, why do we need to store and load data in a lazy way? So that's a question. So, and what data should be stored and loaded lazily? So that's always a question. And how to use lazy references? We have to clarify this. So how could we make the decision that data should stay on the hard disk? Best practices we have to talk about. And there is also always the question how to release lazy loaded data if it's no longer needed. Sources, there are many, but let's try to answering some questions. Basically, or by default, Eclipse Store is an in-memory database framework. So that is one reason why it is so fast and performant, so I have to say. When we're talking about, people always ask me on some conferences or on, is it possible to handle 100 terabytes of data with EclipseStore? And then my answer is maybe yes, maybe no. It depends on what data do we talk about, and why do you have that much data within your application? And then people answering and say, okay, yeah, I mean, we have a huge Oracle database, and that database is running for 20 years now, and that it contains 100 terabytes of data. So, and now a much better question is, do you really need 100 terabytes of data all the time in focus for, and why do you have that? Do you querying 100 terabyte data the whole day and every time? And does this make sense? And what type of data is it? Is it images or log files or binary data? So you see, there is a lot of, and then I ask, why not to archive 80% of the data which is no longer needed, and then just use the 20%, which is the real data which is needed all the time. So, and this answers the question a little bit. Do we want to handle 100 terabytes of data with EclipseStore? You could be if you use Lazy at the end. So, but let's say we are able for adding so much lazy points on your graph that it is possible to run 100 terabytes within, let's say, 32 gigabyte machine. Okay, so we keep all the binary data on the hard disk and just loading the main data, let's say. So what happened if users are starting to work with the data? So, and now the problem starts, because the more concurrent users are working on your data, the more data will be loaded at the end. So that means we are able to start the machine, but at the end, when people starting to work on it, data will be loaded. And the more concurrent user we have, the more data stays in memory anyway, even with JPA. And you would be surprised at the end how much memory do you need on your application server side when people starting working with your data. And in some cases, so I prepared a performance demonstration also based on that. You would be surprised that EclipseStore is much more memory efficient because every user is working on the same object graph than a normal JPA Hibernate implementation. It needs double or third times the amount of RAM when a huge amount of concurrent action is ongoing. So you see, it's necessary to have lazy within the storage itself. But on the other hand, you would use EclipseStore for in-memory data processing and data storing. And I think I would recommend use the right storage technology for the right type of data. And it doesn't make sense to have tons of terabytes within an in-memory database. That doesn't make sense. There are cheaper solutions. Storing stuff into AWS S3 bucket, for example, is much cheaper than having all the heavyweight binary stuff on an Oracle database. Why do you want to pay for that? That doesn't make sense at all. So, and that's why I always recommend for look at your data, and at that time when we talk about microservices and so on, imagine what data could be provided by what type of database, for example. So, and it's possible to have, so let's make the decision. This is the core data. I need this every time. That is exactly made for an in-memory database approach. And I think that's the story behind, and that you always have to consider this. So, but anyway, it needs to be possible that binary data comes into play, and you want to store binary data also with EclipseStore, and that's possible by using the lazy loading. And sometimes, as always, it is not necessary to store everything inside. Historical data, for example, or data which is touched once a day or twice a day. Everything is possible. So, and that's why we need the lazy approach. So by default, that means when nothing special is implemented in the object graph, on startup, the whole data will be loaded to the RAM. So that's how it works. So let's imagine when we have 100 million objects on disk. So at startup, you will have 100 million objects within your RAM. So that's how it is. But instead of having this, we could set some lazy wrapper objects. Let's call it a lazy wrapper. And the object one here maybe is a customer or a customer collection. And that customer collection is wrapped into a lazy object. That means everything below stays on the hard disk on startup of EclipseStore. So then it looks like this after startup. But always keep in mind that when people starting work on this, so that means when one user accesses a collection which is loaded lazily, it will be loaded at the end, and you will take care about the memory consumption anyway. So, but that is really straightforward. So when to use lazy loading? Just a small amount of basic rules. I would say always on binary data. So that means whenever you have binary data, images, whatever else, then use it the lazy way. Blobs, documents, images, and so on. Always on huge collections. So that's now it's the question, what is a huge collection? Less frequented data, for example. So logs, archived data. And so when we're talking about huge collection, I would never say we're talking about lists or sets. Instead of we are talking about maps, for example. So remember what I said, when you use a list, and let's say it's a huge list with a huge amount of data, and you want to stream through, you always have to load the whole list at once. And that's a big issue because data will be loaded, it needs RAM at the end, and that will lead to a crash maybe. So, and therefore it makes sense using maps instead of huge lists or sets, because on a map, you could create your own index, for example, just for searching within a specific range of the data. So sometimes it makes sense when objects having a huge amount of sub-entities. That could also be the case. And yeah, basically whenever you want, if performance isn't that important in this part of the data model, or the amount of RAM is limited. So I think that are the basic rules. One example for the usage of binary data. So this is the basic way how to use lazy. So it's, as I already explained, it's a wrapper class, and it wraps, for example, that binary image here. That means whenever that book class is loaded, then the binary here stays on your hard disk, as long as you call the get method. So that's one possibility for using lazy. And I have to say, this is a really efficient way how to handle this, because that enables you for searching within the ISBN and searching within the name without loading the image at the end. Another situation could be using that with a hash map, for example. The string is kind of like an index, and that enables you storing, let's say, document names or whatever. So that means you will be able to search within and just unwrap the only document which is needed. So whenever using, then it makes sense using it this way within hash maps or directly within one image, one specific image. Okay, another possibility. A lazy list of books, for example. So this could be possible, having that this way. But as I already explained, when someone want to stream through that list, the whole list needs to be loaded to the RAM to stream through and to find something. That could make sense if the list is a smaller list, which is not used that often, maybe once a week or twice a week or whatever. Then it makes sense having that this way. So with a list that is not frequented that often, this could also work. Low and medium sized collections to be aware of maybe huge amount of entities. This is what I would recommend, a hash map for creating your own specific indices, for example, for books. Let's say we could have the first 3 or 4 letter of the ISBN could be an index here with a list of books at the end, just to prevent searching and to load the whole list of books when you search for something. There are many different possibilities, and at the one side you might say, okay, that's interesting, so I have to take care about how to handle the data at the end. That's for sure, that's you have to do this. On the other hand, that gives you the possibility doing that, because when you're talking about JPA and relational databases, you always have to create an object, a model that fits best to your database, right? So it has to fit to Hibernate and so on. And now you are able to use hash maps for storing stuff, and it enables you doing stuff much more efficient than before. And to be honest, there is, or I have to mention it, there is the new component we provide. It's the GigaMap, which is part of the enterprise version. There's a great component that handles that lazy mechanisms automatically in the background. That is an incredible component. So how to release the data? So releasing the data that works automatically. So, or let's say this is handled the manual way. So you always could say lazy image.clear. That will release the reference, I would say. But keep in mind, garbage collection needs to be done after that. So when we have a look to the memory consumption at the end, we will see that the clearance will happen after the garbage collection is running. And there is another way to unload data. This is the automatic way. That means this is running by default in the background. That means after a duration of 30 minutes, if an object stays untouched, it will be released automatically. Or after a memory quota of 75%, the garbage collection and the housekeeping starts to release untouched or lazy data automatically when you reach the 75% of memory quota. So this has happened in the background. Okay, let's have a detailed look to this. I prepared an application for you. Just a second. Oh, maybe it's not loaded so far. Lazy demo, that's what we want to have. Okay, so let me share this with you. It's a project which is already available or also available on GitHub. Here it is. Okay, so this is the link to the lazy demo. I just want to answer that question from Uwe. To be fair, Hibernate provides transaction isolation, which EclipseStore you would need to do by serializing mutations. Yeah, you are right in a way. So I think that's a big benefit of Hibernate. But on the other hand, that leads to using caches in the same way. So that forces you having caches at the end, because otherwise, with a increasing amount of users, you would have thousands duplicates of isolated entities. So the more users they have, the more increases you the thing. So that means that leads to having caches, and that leads to performance issues by the caches, by OR mapping, and so on. So yeah, I think I think there are pros and cons on both sides, and I think it's I would say JPA and relational databases are great databases, and they work for years now. But I think they are quite slow, and I would never recommend to trash your relational database. I would say just choose the most important 20% of your relational databases and put it to EclipseStore to increase the performance by to increase 100 times the performance. I think that's the point behind. So I would never recommend to dump everything and use EclipseStore instead. I think that's not what EclipseStore is made for. But when you have the chance to create microservices and redesign your application architecture or your infrastructure architecture, then it makes sense using EclipseStore or microservices to create smaller pieces of data provider. And this is at the end much more efficient than a big monolithic database at the end. But it's on you. It's a decision you have to do. You will get an incredible amount of performance. But on the other hand, you have to take the disadvantages also. Okay, so give me just a second. I have to prepare that that a little bit. Think about your question and write down your questions during the preparation. So just a second. So I shared this with you. Then I need. So just a second. I need to stop the presentation just to start the stuff in the background. Okay, so this will work. So now I could share the screen again. Okay, here we are. So we clean up this a little bit. And I think I prepared this this example to give you an idea how the lazy stuff works at the end. Let me just check on which branch to start. So master, change to lazy. I think that's okay to start on this, change to lazy. Let's have a look to the data itself. So there is a person domain class. There is one DB. That's also okay. Let's have the controller create. Okay, that's interesting. So what happened here is when I call the create method, do you remember the mockup utils I mentioned earlier? So 1,000 persons are created. I think it's the same here. Yeah, it's exactly 1,000 persons. And what happened here when I call the create method, it runs 200 times and it creates 200,000 persons when I call the create persons method here. So that's okay. So let's have a look to the data structure. So let's jump to the data root. Okay, I already changed this. Maybe we could start at the branch before. So just to make this clear. So let's switch to master. Okay, that's okay. So we have a list of persons, really straightforward, without lazy, without anything. And the process controller here, create, is still the same. And let's give it a try. So let me just check if there is, okay, there is still the data. So I will delete this. So no storages here so far. So let's run this. Application is up and running. So that's okay. So sorry for changing that, that screen that much. So I prepared Visual VM to monitor what happens on my machine. So, so now we should see, CPU is not that important. It's not supported now, but the interesting part is the memory consumption. And you see it's quite low. So we are on, yeah, what is that? 50 megabytes? Yeah, I guess that's okay. So, and now I'm calling on my second screen, I'm calling that method books.create. Or no, not books, persons, sorry. Persons.create, and then we will see what's going on my memory. Persons/create. Okay, storage is initializing, and now you see that the memory is increasing. Okay, so right in that moment, we created 200,000 persons, and it's stored in EclipseStore. So it needs 1.5 gigabytes. Is that right? I'm not able to do the garbage collection. Maybe when we wait a little bit, it will be much lower. Let's call this again a second time. That's the second call. It adds again 200,000 to the collection. And that's it. Now it's stored. Now we have 400,000. We could have a short look to the storage, just to give you an idea how big the data it is now. Refresh. So that's the data folder. Show in System Explorer. Just to give you an idea. So that's the data folder. Let's click here, and we see now it's around, I don't know exactly the reason why it's the size on the disk and the size itself, but it's around 3 gigabytes now. And it took us a little bit less than 3 gigabytes in RAM. And that's interesting to see or to estimate the memory consumption of how much memory do we have on disk and how much does it takes. It depends, of course, it depends on the type of variables you use. So primitive types are more cost efficient than big objects because of the missing reference. So so whenever you are able to use primitives like the small int or the small double, for example, makes much more sense, prevents references within your storage, and will also lead to a better performance within the RAM. But I think that's okay, seeing that the comparison between memory and disk space. So what happened when we restart the application? So data is stored. Now let's close this, and we no longer need this. So and now start up the application again. So, and remember, when we talked about within the presentation, on startup, the whole data will be loaded to the memory. So let's get into it. But I think that's a good opportunity to see the real memory consumption with garbage collection. So let's call just the persons. So now the data should be loaded. Yeah, we are at the same, let's say, so this is the way, how long does it take to load 400,000 persons the lazy way, you know? This is the startup of the storage, and the data has to be loaded from your hard disk. When we now call that this again, it will be much faster. Then it comes from memory, and everything is much more faster than any other call to a database because it's in memory performance. Okay, any questions so far? That is really straightforward. Without lazy loading, we will have the same amount of data at the end also in the RAM compared to the hard disk. How do you handle EclipseStore and additional data in general, like pictures, doc, and so on? Yeah, I think that's a question that is, it was the same question also on other databases, just storing the string references or the paths to a specific image or picture. I think it depends a little bit on how often are these pictures are needed, and how so you always have to consider that when a picture is part of your database, when you load it, you always have to process that picture through your application server. So that means everything which is part of your database has to be streamed through your application server. That means it increases the amount of performance of your application server. Instead of having a system like, for example, any binary storage on the market, like AWS S3 bucket, for example, or whatever, that provides the data without streaming it through your application server. So that means you could store a link and you could direct link to that resource, and this resource will stream directly without touching your application server. So there are many advantages having binary data not in your database. But is this an all-over recommendation? I'm not sure. I think it depends on the situation. It makes sense having binary parts within your database for many reasons, but I think it's much cheaper and much more efficient having data outside of your database. Even if that leads to managing references and URLs and what else, it is what it is. So yeah, but yeah, I think it's much cheaper than storing everything on a very expensive Oracle database. Yeah, it's on you. Okay, so let's switch this to lazy. So let me delete this because we are switching to the next branch. Switch to change to lazy. I think it makes sense that, just to make sure that yeah, let's do this. Let's start this. But I enable the lazy checker. So Oh, come on. So that's this. So I enable or I change the default behavior of the lazy reference manager, and I will set it to 1 minute. So that means after 1 minute, the data is loaded. It will be released after 1 minute, just for the training here. So this doesn't make sense that often. Maybe yes, maybe not, but just for demonstration purposes, I add this. And yeah, let's start it. So let's give it a try. So this is no longer needed. Or is it still? That's the new one. Okay. Okay, data is now managed the lazy way. So let's have a short look. Now you see there is a lazy list of persons. And at that moment, when we're storing data in it, of course, the data is part of, is it? So let's call the create method on my second screen, persons / create. Then we will see that memory is increasing. This is what we're expecting. So because we have to load the data first. So now 1 minute later, or after the next garbage collection run, and this is quite a shame that I'm not able to click here, we should see that data or storage should go down till 50 megabytes, for example, because it releases all the data after 1 minute. I think it's because the version of the JVM that I'm not able to call the garbage collection. Yeah, maybe anyway. So you see that the storage is slightly higher than before. The reason for that is every lazy. Oh no, no, that's not the reason. I think it's because we are storing that thing. Oh, come on, that's a shame. But anyway, let's stop this and start the application again, and then you will see that data is not loaded on startup, and I think that's an important important part. So let's do this and run as. So now there is one special interface that I created within the person controller, just to initialize the storage without loading the data. Loading the data or calling the getPerson method would lead to that the data will be loaded because I'm calling the get method. But just initializing the storage with init, you will see that storage is initialized. And when we have a look to the monitor here, you will see, okay, there is only the lazy reference is there. It's slightly higher than normal, but the data stays on the hard disk till the moment it is loaded. So this is how the lazy behavior works. Okay, let's move on to some helpful structures that could help you to handle the data at the end. And that leads me to the next branch. Team switch to multi-maps. And that's so I would say this is the recommendation we did before we invented the GigaMap, for example, because using the GigaMap will makes it possible to prevent these, let's say, complicated way storing the data, but it is possible to have it like this. So you see there is one class which is called person. This is the person itself, first name, last name, male, gender. And there is a second class which is called persons, and this persons class contains multiple maps with different indexes for having the same persons. So that means you could have the persons indexed by male or indexed by last name. And this, let's just check this in the first by last name. It's the last name substring of 2. That means the first 2 letters of the last name creates the index. And it's the same on person by male. The first 2 letters of male creates the index of persons by male. So now you might say, does this doubles the amount of RAM what we have? And I have to say it will not, because there are only references that we have within that map here. So the person object itself is available once, but we have only the workload of the references. That is doubled, of course, but not the person itself. And that provides us the possibility having multiple maps like this. And this will lead to a lot less memory consumption at the end, because you do not have to load the whole list of persons at once. You could search within your maps and using different ways of storing data. Another solution would be the GigaMap. And I want to step in this just for a short moment, because this is not part of the training. The GigaMap is a new invented collection which looks like this at the end. So it's just the GigaMap itself, and it uses lazy technology in the background. It handles multiple chunks, and it releases that chunks self-managed, I would say. And on top of that, you will be able to create your own indices based on the elements here. For example, there is a book index of the title of books. So that means you will be able to search within the GigaMap by title, by ISBN, by published date, and so on. There is a huge documentation, which is still work in progress. But as far as I know, it is released now. The enterprise version is released. You could give it a try and check it out, how this GigaMap works. And it's a great solution compared to, for example, this one. I would say it's much easier to handle, of course. And it manages all that heavyweight, lazy stuff in the background totally automatically. And this enables you having, terabytes of data also within GigaMaps within EclipseStore. So also give it a try, check it out. A more detailed dive into the GigaMap will be within the Advanced 2 training. But this is next training, I have to say. Okay, so any question to lazy loading so far? Just check out the lazy demo project. There are some more implementations here. For example, I already mentioned this in that Micronaut EclipseStore demo. There is one implementation which is also interesting with Lucene. So there is, let me just check storage root. No, there is, moment, where we have it. Yeah, no. Come on. So, yeah, here it is. Okay, you see that there is a map and the same structure than we already seen on that lazy project here with books, with list of books. But on top of that, there is a Lucene index that is working behind, and it creates the index for searching within the title, searching within some other elements of books. And at the end, you will get the right index of the book, and that enables you to search within Lucene and load the object directly from your collections. You might say having Lucene doubles the effort within the programming, but it's not the case. When we have a look at some other technologies like having let's say Lucene or Elasticsearch server in between a relational database and the application server, it's the same amount of effort dealing with the cache in between, updating the cache and doing stuff like this, then it is in the same way efficient like doing this directly in your application. This will lead to the same effort at the end. Okay, just to give you an idea of what's possible at the end. Good point. What happens when you change the structure of your persistent entities? That's the next topic I want to jump in. And that is quite an easy topic because at the first level, it works in the same way or much easier than with all the other compared to all the other databases. There is a moment, lazy loading, legacy type mapping. So the system which is working behind what happens when data changes, it's called legacy type mapping. And it works kind of like a versioning. So the question is, how does EclipseStore handle data types? That's important to understand. Then you will understand how the legacy type mapping works in the background. And what happens if we do some changes? And what changes can be handled by EclipseStore automatically? Okay, so how does EclipseStore handles data types? So I'm not sure if Florian mentioned that in the fundamentals training, but when we jump to a specific project and jump into the storage, for example, here, when we open that persistence type dictionary, so for example, here, so that is the persistence type dictionary. And you see that every object that can be stored to the storage is registered here. So in each storage, each type has its own type ID, which is listed here. It's type ID 57, 58, and so on. And when we scroll further down, so we will see that there are here all the individual types occurs. For example, we should see the person somewhere here. So just a second. Person, no, that's not here. Maybe here. We have data root here. Here we have the person here. That's the person object. So that means every object which is stored within EclipseStore consists of an object type ID and an object ID. So that is how it is stored. So, and that means at the end that that's the persistence type dictionary, and every element in the storage has its type ID and its object ID. And the persistent type dictionary works like kind of like a versioning. So that means when this is an example of change of a customer. So ID, last name, first name, mail, gender, and we add an additional field, IP address, for example. That's the new one. What happens in the background? In the background, the EclipseStore creates another type, which is with a different type ID, 67, compared to 66 before. And whenever you touch an old object within the storage, it will automatically transfer to the new version. That leads, at the end, that leads to a situation where you have maybe 50% old objects and 50% new. It depends on you. When you load every object, every person, for example, and when you close it again, it will be transferred fully to the new version. So, but you don't have to care about this. This happens automatically in the background. And an interesting question is, what can be handled automatically? And I have to say, everything that also could be handled automatically within any other database on the market. So that means moving, for example, moving an attribute to a different place. So for example, first name moves up to the first place. renaming, so that behind the scenes there is an heuristic working, and that heuristic checks based on position within the class, name, data type, and so on. And it could easily, and I have to say it's quite, I have to say it's hard to create a situation where the heuristic not matches the right thing. And so that means whenever you rename something, whenever you moving something, this will be handled automatically, or when you add something. These are all situations that could be easily handled automatically in the background. This is what happens after changing something. It shows you the how to say, the heuristic, and it tells you, okay, so first name moves to a different place, the data type is the same, the name is the same, this is 100%. Name has changed to last name, it is the same data type on the same position in the class, and it is it guesses that 75% is the same match, that something has changed, and it's the same on the next. So mail changed to mail address, and so on. This is how the heuristic in the background is working. And it asks you to say, is that okay, doing those changes? And then you could say yes, and your storage will be automatically transferred to the new version. This is the automatic way. There is an additional manual way, but this is part of the advanced. Let's jump into legacy type mapping, how in practice. So I created a project as always, and I want to share this with you. Give me just a second. Legacy type mapping. This. And I'll link you that. Okay, that's the project. We're starting on the master branch, and let's have a look to the domain class. It's all about the author. So we have mail, first name, and last name. That's the author class. And there is no storage so far here. So let's start this, create some data, and run as Java application. I will do the creation on my second screen. There are so many. I think there's authors, author controller. I just have to authors create. Okay. Authors/create. So storage is initialized. Authors are created. Oh, it's just only one, but it's totally okay having just one author here. So mail and first name and last name. These are the elements. So now we stop the application and see the storage is created. Refresh. And when we jump into the type dictionary, we see that it is created here, an object named author, far away down here. So with the object ID 69, author, mail, first name, last name. Okay, good so far. So now we change the branch. Switch to, where is it? Code. It's late at night. So stage 1. So now we see that when we jump into the author, we see that now the name has changed from mail author here, and last name is changed to name. The data type stays the same. And now let's start the application. And let me just double check. Resource. Okay, here you can see set legacy type mapping resulter. So in that example, I forced the storage to ask me about doing those changes. And when I now start the application, run as, and on storage initialization, so you just refresh that here. Now you see he asks for the changes. You see, okay, mail has changed to mail author, and first name stays the same, first name and last name. This is exactly, and he asked me yes to accept the mapping, and that's it. And now you see here, these are the new result, and you see mail author a name, so it's automatically changed. And when we have a look to the persistence type dictionary, you will also see that the second type occurs here, another author with a different ID. And that's how the legacy type mapping, I would say, step one, automatic mapping, is working. So now the question is, what are the limitations of that system? Well, I have to say the limitations are the same limitations than in any other database. Because let's talk about data type changes, for example. Let's say we want to change something from string to integer. And now you see the problems at this, but it's not a problem of EclipseStore itself. It's the same problem on any database on the market. So you have to do some sort of migration logic to migrate one field to another. And there is some business logic needed behind the scenes to transfer the data. And I think that's exactly the same also on EclipseStore. So my advice would be, when you have some such heavyweight changes, for example, changing a data type or something else, just create a second attribute down below, and on startup you migrate the data, for example, or you use your get and set methods to migrate during the application working time. I would say I prefer to migrate the data at once. That's what we mostly do in our projects, because I don't like that business logic that is needed then all the time within the get and set, and you will never know if you could remove it or stuff like this. So I would prefer changing it like this. Let's say, yeah, whatever else, but it's and starting the application, doing the migration, and then deleting the old stuff which is no longer needed. But most of the time, the heuristic and the automatic stuff is doing a really, really great job. And for those of you who say, okay, I'm not able to trust on that heuristic, so sometimes maybe that will not work. There is a manual way, just to give you an idea. It's not part of the Advanced 1 training. There is that topic which is called legacy type mapping, and everything I explained to you is totally covered here in it, with all the explanation and some more crazy stuff. And there is that explicit mapping. And with this mapping, you will be able to create a specific file. And within that file, which is called the refactoring CSV, you will be able to make a really clear definition of what should happen when you transfer, or when you what happens. So that means that enables you to describe the whole changes that happens at the end. To be honest, in all that project for the last 5 years, I never used this CSV system, because I'm totally fine with that automatic stuff, creating a backup in the background, and then doing the transfer if there are some heavyweight changes in it, works totally fine for me, instead of using that explicit mapping. But it's up to you. It's possible. And within the Advanced 2 training, we give it a try and see how it works. And that's totally fine. It's working. And this is how the persistence legacy type mapping works when data changes. I hope that answers your question, Uwe, regarding that topic. Okay, so last but not least, and I have to cover this, and this is why, because that's an important topic, but we are good in time, is how to create a backup. And that's okay for having that topic as last topic for today, because it's an easy topic. It's quite easy to handle this, because most of the time this works in an automatic way. As always, I'd like to share the project with you with several branches in it. Backup strategies. Here we are. So here's the project. So there are two main backup strategies that comes out of the box of MicroStream or EclipseStore. So the first backup strategy, we call it the continuous backup. And the continuous backup is kind of like a mirror. That means whenever you write to the primary storage, a second storage grows up and beside the main storage. So let me show this to you. So hopefully we are on the right branch. Continuous backup done. Yes, it is. So let's go to the DB class. And it's really, really quite easy to set up. In that case, I used the XML file, and you see there is one property which is called backup directory. And when you set this backup directory here, it could be a second mounted persistent volume, for example. It could be a different path on your hard disk, whatever. That mirror will be written whenever you write a single store. And in that case, there is, backup directory. It doesn't really make sense having the backup in the same directory like the data itself, but it's just for demonstration. So let's backup strategies. Here we are. Okay, no storage here. Okay, let's start it. So again, I call this on my second screen books, I guess. So books/create. So books are created, it says, and let's call it, okay. 4 books are created. That's the result. When we now look at the storage itself, when we click refresh, this is the data folder, which contains our primary data with 4 channels, like configured here, 4 channels, data, everything is like it should. And there is a backup folder, and you see every time it creates directly a mirror. And this mirror can be everywhere. This mirror could also be part of an AWS S3 bucket or a binary storage, whatever. It's totally up to you. Or even your JPA database. It's possible to write that mirror to an Oracle database, for example. I don't know why this could make sense. Maybe because there is already a backup functionality for an Oracle database or whatever, but it's possible. So, and what happened if my database crashes? So let's say something went wrong here. Then we just have to copy this and replace the original files. Let's do so. So let's delete. Yeah, don't know if this really makes sense, but show in. So that's the data, that's the backup. So let's delete this. And now we copy this. Okay. And now we are able to start the application again. And when we now call, there it is, here it is, so refresh, we will get the same data. So, and this works totally out of the box. Using that Miro is a really great opportunity for having a lightweight Miro that grows with the normal storage in the same way. And that's the first stage of backupping stuff. The second stage is a full backup. So, and the full backup is also an embedded functionality, and that's important that that is, let me switch to full backup done. Here. Stop it. So with one restriction, so the full backup is only one line of code within your application. And you have to take care about doing this within a specific period of time. So once a night, every night at 12 o'clock. And for this functionality, we recommend to using Quartz, like we do here, or like I do. And there is a specific Quartz scheduler and a Quartz job. And what happened inside that job is only this line of code. So db.storage manager issue full backup. So this creates a full backup whenever that Quartz job is running. And this is a quite important point because some of our customers try to create some copy of a specific mounted volume, for example. There are some copy functions and creating a clone of a persistent volume, for example. But this is really dangerous because you never know if EclipseStore writes data at the same moment or at the same time you're cloning the files. And I would say this will work 10 times, and at the 11th time, it will crashes the storage, or it will crashes the backup, I have to say. The storage will, I think the storage will be okay, or will be fine with that. But the backup will be damaged or whatever else. So, and that's the reason why you need to do this in the same thread like the storage runs, because at that moment you create the full backup, it is part of the same queue, and it ensures that you create a valid backup of your storage, and that's it. So as an example, I triggered this every minute. Then I would say, let's start, just to give you an idea. So, oh no, wrong class. Application, here we are. Just a second. I have to do a Maven update. Okay, looks better now. So there is no storage so far. So book/create. Okay, books are created. Let's double check. Yeah, well, okay, books are here. And now we should see, oh, there is one backup successfully done already. So now we should see that full backup So this is the primary storage here, and that's the full backup, which is created every minute now because my Quartz job did that every minute. So the more your storage grows, the more it will take to create a backup, a full backup of that. Of course, when we're talking about having, let's say, 100 gigabytes of data, then you always have to keep in mind that a full backup will create a second. So 100 gigabytes of data has to be transferred to somewhere. So that's the reason why we would not recommend doing not recommend doing a full backup every hour, for example. I think it's okay having a mirror, a continuous backup the whole week, and doing one full backup every week, for example. So, but it's also up to you, and it's up to the size of your storage. It depends. So I get an exception here because the data is still there, and there is no business logic to override so that's why it crashes now. But I think it's important to give you an idea. These are the two backup functionalities. We are currently working on some improvements on that backups for having that full backup may be non-blocking. So we are working on that. So there are some features, so upcoming features next. But for now, these things are working great. And it is the recommended way. And last but not least, I want to share with you one thing that makes totally sense to me also, because continuous backup should be mostly on a system which is different to the current running system. And that's why I created another example which has the primary storage on the hard disk, and the continuous backup is written to an AWS S3 bucket. Just to give you an idea how to configure this. I did this based on the embedded foundation. So I have to say the more complicated way to initialize the storage, but I'm pretty sure this is already available in the builder pattern. But I have to update this in some further trainings. And this works really great, so that the main storage is on your hard disk or on your persistent volume, and the mirror is on an AWS S3 bucket. It's a great opportunity for backupping stuff, and I think totally enough for any backup strategy that you need. Okay, any questions from your side regarding backup? Okay, no questions so far. So it's late that day, I guess, and most of you. Okay, let's go through the topic for today. So we talked about, we created a project exercise. We talked about advanced configurations and Micronaut integrations and how to configure storage. We talked about advanced storing, eager lazy storing, transactions, rollback, exception handling. We talked about lazy loading and how to use it, why to use it, and so on. Legacy type mapping, what happens when class changes are backupping EclipseStore, continuous backup, full backup. And I think I answered a lot of questions from your side. We are right in time. That's all from my side for the advanced one training. I hope it was interesting for you. I hope it was not that boring, and it helps you to use EclipseStore in further projects. I will stay 5 minutes or 10 minutes longer, so if you have any questions, feel free to ask it. And then after, even in German if you want, it's totally up to you. I have to say thank you. I hope you enjoyed the training. I hope we will see us on the Advanced 2 training also. And yeah.
Christian, I have a question about the Advanced 2 training.
Yeah.
When will this take place, and how do I get invited?
Yeah, that's a good question. I don't have the there is no appointment so far. It will be somewhere within the next 2 weeks. But I don't have the exact time slot. So but I'm pretty sure that we will send a newsletter within the next few days. So that let you know when it's take place.
Okay, so through the normal channels that where also the other trainings were
as always, yeah.
announced. Okay.
Yeah, Uwe, that's quite complicated topic. There are a lot of different ways without using synchronized and serializing, because Java comes with a lot of different possibilities like final modifier and immutable stuff and so on. It is not that easy. So I would say synchronized is the worst way to handling concurrencies, because it separates, or it locks reads from reads and also reads from writes, and that leads to a mostly performance bottleneck. Mostly the problem, or the big advantage on EclipseStore is that accessing RAM is such a very fast single action, I would say. And this makes synchronized, I would say, okay. Yeah. But there are better ways. For example, the reentrant read-write lock that can be used for accessing collections and so on. That's okay. So to be honest, when we're talking about the project we implemented EclipseStore, it depends always on how many people or how many concurrent users do we have on that system, and how is the chance that something happened when, for example, the worst thing that can happen is a concurrent modification exception on a specific collection, for example. And yeah, one atomic operation is that fast that you will need a huge amount of concurrent users to having trouble with concurrencies. That's yeah, I don't know if that is I think it's a huge topic. That's also the reason why it's part of the Advanced 2 training. And we have to talk about this more in a more advanced way. But I can guarantee you this is not a really big issue. So not more an issue than with all the other technologies. So you have to talk. So when we talk about locking and concurrency handling, we're not only talking about technical concurrency handling. We're also talking about what about locking in case of business transactions, for example. And this is a topic which has to be handled also in all the other databases. And yeah, I think it's okay having that in the Advanced 2 training, and I think it's a good place to talk about concurrency then within the Advanced 2 training. Enjoy EclipseStore, and thank you, and bye-bye.